Okay, problem number 2 from the quiz was looking at writing and balancing chemical equations. So I gave you 2 reactions, but I didn't tell you what the products are. In class, we've covered single displacement reactions, double displacement reactions, combustion reactions, as well as acid-base chemical reactions. Now, as we are going through different chemical reactions, what that means is you should be able to predict the products when you're given the reactants. C3H8 is a hydrocarbon, carbon and hydrogen only, reacts with oxygen. So that is a combustion reaction. Carbon dioxide, CO2 gas, is going to be one of our products, and the other one is water, H2O. Gas and liquid. Don't worry about the phases in this situation because that won't actually impact when we balance this. Reactants, products, so we're good. Now we have to balance. I have oxygen, diatomic oxygen. I have oxygen in CO2, oxygen in water. So we don't want to touch the oxygen right now because it's in 2 different places. 3 carbons, 8 hydrogens. So regardless of which one we balance, it's probably a good place to start here. So what I'm going to do, we have 3 carbons here. So let's put a 3 in front of CO2. The carbons are now balanced. 8 hydrogens. We only have 2, so we put a 4 in front of the water. Carbon is balanced, hydrogen is balanced, but of course oxygen is not. We have a total of 6 oxygens from CO2, right? 3 times 2. And we have a total of 4 from water, again, 4 times 1, so that's 10. So we have a total of 10 oxygens. Well, O2, the easiest way to get to 10 is just to have 5 moles, to multiply it by 5. This gives me a balanced chemical equation. Carbon, 3 carbons, 3 carbons, 8 hydrogens, 8 hydrogens, and now 10 oxygens, 10 oxygens. I would read this as 1 mole of C3H8 reacts with 5 moles of O2, produces 3 moles of CO2, and 4 moles of H2O, of water. So we have our products, we balanced it, and now on to the next one. This was a combustion reaction, burning a hydrocarbon. The next reaction, well, you should recognize you can call this a double displacement reaction, which is perfectly correct, or you can also notice that this is actually an acid-base neutralization. Calcium hydroxide is a base, OH. Perchloric acid, HClO4, is an acid. Even if you didn't recognize that, you could still solve this as a double displacement. Hydroxide is -2. Calcium is +2. I'm sorry, hydroxide, we have 2 hydroxide. Let me walk that back. Hydroxide is -1. We have 2 of them, so that's an overall -2 charge, which is fine because calcium is +2. Perchlorate is -1. A proton, H, is +1. So just writing out these charges will hopefully help us. Now, in the case of an acid-base reaction, we're going to make a salt, which will be calcium perchlorate, and we're going to make water, H2O. So, and I'll put the charges in, again, with a different color. Get these out of here. Just to highlight that. So perchlorate has a -1 charge, but calcium has a +2 charge. Before I fix that, aqueous. H2O is our other product. I noticed some of you were doing this, which is H2O. Not wrong. So, but it is important that you kind of start to get a little bit more understanding of, when I look at this formula, okay, HOH, well, you just made water. It's H2O. So we have our products, but something that should stand out right now, calcium is +2, perchlorate is -1. So the only way to make this a neutral compound is to have 2 of the perchlorates. So CaCl4, 2. So there are 2 perchlorates for 1 calcium. H2O is fine. So now we have to balance it. We have 1 calcium, 1 calcium. That's fine. We have 1 perchlorate. Notice we have 2 perchlorates. Kind of running together. That's fine. Aqueous. I'm using different colors simply to try and differentiate the numbers. That way it doesn't look like I just wrote 42. And then this aqueous. So 1 ClO4, 2 ClO4s. Notice I'm not taking the time to count individual atoms. Perchlorate is intact on the product, on the reactant side and the product side. So I can treat it as 1 unit. Well, if I have 2 of them there, I'm going to need 2 of them here. 2 perchlorates, 1 calcium, 2 perchlorates, so that's fine. Now we look at hydrogen and oxygen. This actually tells me I've got 2 additional oxygens, 2 hydrogens, but we're actually having 4 hydrogens. So let me go through that math again. So 2 hydrogens from HClO4, 2 hydrogens from calcium hydroxide, and we have oxygen. We've got 2 oxygens. Over here, 2 hydrogens, 1 oxygen. So, putting a 2 there, now we're balanced. 1 calcium, 1 calcium. 4 hydrogens, right? 2 times 2. 2 oxygens, and again, I'm not counting the perchlorate in that count. 2 oxygens, 2 oxygens. And then we have the perchlorate. We've got 2 of them here, and we have 2 of them there. Okay? So 1 to 2 to 1 to 2 molar ratio.